Hello there, students. We're going to go over coming up with a linear regression model for today. We've done this in the past. We did this in chapter 4. Today I'm going to show you a shortcut of what we can do. So what we're going to do is, if you look at number of observations, okay, that right here just is a sample size. So we have 8 samples. We have a person who is 15, 25, 35, 45, 55, 65, 75, and 85, and then their sound levels of what they can hear. So we want to see, is there a relationship between your age and the sound level that you can hear? Okay, so first thing we want to do is we just come in here, we want to make a scatter plot. So you just hit, okay, insert, okay, or you could choose graph. So I'm going to make a graph. So I don't want a column chart, I want a scatter plot. Okay, and then for the scatter plot, so we have it here, okay, does that look like a line? So we could see, yes, it looks like a line. So as their age increases, we could see the sound level, we could see the increase in, or I should say, their sound level takes more, higher level sound level for them to hear. We want to edit the chart. We're going to go ahead and put a chart title. So the chart title is just going to be relationship between, we'll go between age and sound level. Okay, we're going to make the horizontal axis, so that's here, this is our age, and our vertical axis is the sound level. Okay, horizontal, that's our x-axis, and then our vertical axis, which is our y, is labeled. So that's all we have to do for our chart. We want to see, is there a relationship? Yeah, we can see it's a line. Sometimes if it's all over the place, we can see it's not a line, so we would question whether to use a linear line for this. So we're going to move it down here. Okay, the rest of this is actually pretty easy. So what we're going to do is we're going to go ahead and use extensions. We're going to use the Excel minor pack. And then we'll come down here and we want a linear regression. That's a line. We're going to put in our Y values. Our Y value is going to be our sound level. So I'm going to go all the sound level and then highlight. So I highlight that column and then I put it in that cell. Then I want to come here, I want the age, so I'm going to highlight my age, and I'm going to put it in that cell as well. We are using labels, so we'll put labels in there. And then our output range, so where do we want this chart to show up? I'm just going to move it, I want to move it over on this side, so I'm just going to come down here, and so I'll have it show up in H3. And then you can just hit OK. So then it will show up. Now, for today, what we're going to use is we want to know what our slope is and what our, our y-intercept and our slope. So it says, hey, what is the slope? The slope is this right here, the coefficient for the age. So we can say our slope is 0.40, we'll say 7. Our y-intercept is this first one, coefficient, so it's 47, 47.89. 3. Okay, so we did our scatter plot. Now it says find the predictive for someone who's 60 years old. So our equation, so if I did an equation, it'd be y is equal to my slope, 0.407, times my x value, so times x, plus my y-intercept. So my y-intercept is 47.893. Okay, so if I want someone who's 80 or 60 years old, that's just my y value. So I just hit equals, and then I click, and I'll use these ones here. So I'm just going to click, hey, my slope times my age that they wanted, 60, plus my y-intercept. Hit enter, and so the decibels that we would expect them to hear at would be 72. Okay, so we want to calculate the residuals, so we're going to find here our predicted y value. So we're going to use the equation to come up with a predicted value. We know what it is, so this person is 56. So we're going to hit our predicted y value just equal to our slope. So we click on our slope, 0.47. Now remember, we want to lock it in, so we just put a dollar sign around the I, okay, around the letter, whatever letter it may be. It's not necessarily times my x value. My x value is this 15 plus my y-intercept. Again, we want to put a dollar sign around that letter, so that way it locks it in. We're always going to use that as our y-intercept. And then I hit enter. Yes, we want to fill it out. And so that's what we get. And so we could see, hey, 58 corresponds to, and then we'll just go here. We want to change this all. We're going to go to the nearest. So we want to go to the nearest whole number. So 54 corresponds to 56, 58 to 57. So we can see they correspond, and they're pretty close to it. Okay? So then our residuals, okay, is just our y value, and I'll space it out. So this is just equal to our actual y value minus our predicted y value. And then you hit OK. So you can see your residuals are all pretty close. Two of them are exactly on because they're 0. Okay, so we calculate the residuals. It could ask, what's your highest residual? Okay, so my highest residuals is -2 and 2, so we have a lot of them that are pretty high. So the age of 25, or age of 35, 45. Okay, find the standard error of the estimate. The standard error of the estimate is right here. Okay, so that's the standard error of our estimate. So we would just put that in there. Standard error of our estimate is right here, 2.053. That one we'll use over later. But so our standard error is 2.05, and we'll say 3. Again, standard error of the estimate is right up here. We just use that value. So again, we go to our extensions. We do the XL minor pack. Under the XL minor pack, we go to linear regression. We put our values in. From the output, we use these 3 values. Our slope, that one's our y-intercept, and then our standard error.